Alright, so this is TIDA 1070. This is the airflow monitor for the HVAC systems to monitor the actual efficiency of the system, to let the user know whether or not they need to change the air filter, as well as preventing the system from freezing in the event that the air filter is clogged. So as you can see here, this is the layout of the board. Down here you will see this is the actual main power supply. This will be hooked up to the 24 volt transformer within the air handler. Next to that we have our rectification, smoothing. So this section right here is all for taking this 24 volt AC signal and giving us a DC signal that we can work with. We have a 5 volt DC power supply here for external devices if you should so want one. We have a power jumper here. We use this for monitoring the actual current consumption of the device, as well as disabling the device. Here you can see we have our sensors input. Those are for the actual piezoelectric sensors. Next to those you can see the filter bypass sections. The bypass allows you to either feed raw data into the MSP430 or actually go through the filtering system. These filtering systems, you can see one right here and one right here. These are the filters. You can look at the schematic if you'd like the actual layout of it. We also have voltage supply selects. This allows you to put a DC bias voltage on the TLV 4313, the first op amp for this device. Right now we've got it in the position for a 1.65 volt DC bias. As you can see here also, we have these that we can take off and test the current from there, as well as disabling the filter output. The LMT84, this is actually where we are measuring the temperature with. We have the pins here as well to disable it and to allow us to do current measurements. Filter reset right here. This is the button that we use in order to calibrate the system. It will run through 100 samples and then it will calibrate the system based on what data it gets. Here we have our MSP430 FR2311. Again, it's got the jumper pins there so we can actually take measurements or disable it. We have our header buttons here, or our headers right here. As far as the headers go, these headers are designed for the CC2650 booster pack, which allows us to have wireless capabilities. We have power and ground connected to it, as well as some of the signal outputs that we have for the system that can be actually relayed to the CC2650 and then relayed to the customer. As far as these are header pins that actually output to our relays, and here is the JTAG connection right here. So like I said, this device right here works in sync with this one right here. This is a solid state relay. This is a TIDA 751. This is the solid state relay, so this is where our AC voltage would go. This would connect or break the connection between the outdoor condensing unit, so we would not have the compressor running anymore. And then this is the 3.3 volt input right here, which is what would come from our design. And this is pretty much the basic layout of this design. Next we'll go into actual simulations.